what is co-immunoprecipitation? It's essentially an IP of a GFP-bait, and together with the GFP-bait, you immunoprecipitate a second protein, the prey protein. So this is used if you would like to identify interaction partners of your GFP-bait. The GFP-bait is directly precipitated, and the bound prey proteins are then subsequently analyzed by Western blot or by mass spectrometry. Again, I would like to make a short introduction on controls, and then we add 3 different problems: no pull down of the GFP-bait, no pull down of prey, and unspecific pull down of prey. So if we talk about co-immunoprecipitation, we have to talk about controls. These are absolutely important to confirm your results and to see if there is a problem, where the problem is. The co-immunoprecipitations are usually analyzed on Western blots and not on STS page. In our example, we use, again, antibodies against tag GFP and an antibody against prey. Often a loading control is added, for example, GFP-bait, but we don't show that here. So what can we see here? We have here in faint green our positive control. The positive control shows on the left-hand side the input, and then on the right side is the bound fraction, which is called here IPGFP. So we first would like to check if our immunoprecipitation really works, and we add therefore one fraction the GFP, and in another experiment the GFP-bait. And after immunoprecipitation, you can confirm that the GFP band is there in one experiment, the GFP-bait band is there in the other experiment. The second control we would like to include is the negative control. The negative control is once the prey, and in the second experiment, prey and GFP. In input, you can see one prey band, and in this other experiment, a prey and a GFP band. If you conduct an immunoprecipitation, then you see in the bound fraction no band for the prey protein, and you can see just a band for the GFP protein and not for the prey protein. And then if you conduct the proper co-immunoprecipitation experiment, which is here in bright green, you have in the input the GFP-bait protein and the prey protein. And if you do an IP, both proteins must be detectable by Western blot, in the Western blot by the prey antibody and the GFP antibody. This is how a really good working co-immunoprecipitation looks like. And if you achieve that, I can really just say congratulations. So we come now to our next case. What happens if we face a problem? In this case, there is no pull down of the GFP-bait. The input looks essentially the same as expected. You can detect the GFP protein, you can detect the GFP-bait protein, the prey protein, and so on. But if we look to the bound fractions, we can see that the GFP immunoprecipitation worked well, but there is no band visible in the red circles. So the GFP-bait band, which should be present there, is not visible in the positive control. The negative control, again, looks good. But if you look in the proper co-immunoprecipitation experiment, you cannot see prey and you cannot see a band of the GFP-bait. The solution is to see why the GFP-bait immunoprecipitation does not work. Maybe the GFP-bait is not soluble, or just smaller bounds of the GFP-bait are precipitated. So we really have to see what the problem is, and we really focus in this case on the bait protein. As we discussed previously, in the case no pull down of GFP protein of interest, You have to look if the protein expression is working well. You have to check your cell lysis, and you have to optimize your immunoprecipitation. You have to do a proper mixing of the solutions. You have to test different matrices. You have to check if you really use 25 microliters of beet slurry. So, but essentially is you have to see that the immunoprecipitation of the GFP-bait is working. The second case is that we look to the immunoprecipitation of prey, and there is no prey visible. So what's the difference before? Again, the input looks really good. The positive control, the negative control, and also the input of the proper experiment shows the pattern, the expected pattern. Also, the positive control looks good. You see a GFP and a GFP-bait band there. Also, the negative control looks really well. But what you do not see in your proper co-immunoprecipitation band is the prey protein. So why is there no prey protein? One reason could be that the prey protein is not soluble or unfolded. Maybe it's also not efficiently precipitated, and you can see only very small amount, or you precipitate only small amounts which are below the detection level. So the solution is you have to optimize the conditions for prey. You have to test different cell lysis buffers and binding buffers. You should also consider whether there is really an interaction between bait and prey. It's also possible that if you use a bait protein with a tag, that the tag interferes or prohibits the interaction. So that's really tricky, but really focus if with prey, the expression of prey is everything is okay. The next problem is if we have an unspecific pull down of prey. Again, the prey input, or the input looks really good. But you can see that in the negative control, you can see two bands which should not be there. And this is an indication that you have an unspecific pull down of prey. And here you can see how important controls are, because if you look at proper experiment, you see the prey and the GFP-bait band. So the proper co-immunoprecipitation results look really nice. But when you have a really careful look to your negative control, you can see these additional bands. And this really indicates, or is it not indicates, this is a proof that somehow your results cannot be trusted. Why is there prey protein detectable in the negative control? We assume that normally prey should be unfolded or aggregated so that it binds to the beads in a non-specific way. The solution, again, you have to optimize the conditions for prey. Test different cell lysis buffer and binding buffers. Do these tests without the GFP-bait. Just optimize the conditions for prey. And once you found good conditions, then you have to make the whole test together with the GFP-bait protein. So this is a very good example how important proper controls are.